Okay, the following is a video on how to apply and use the sine, cosine, and tangent functions to find the trigonometric ratios. So remember, the one thing that we need to realize here is that we still need to use that saying, so katoa. All right? And that'll help us figure all these out. So what I want to do, let's do part A first, where it says sine of angle J. So here's angle J. All right, so if I look at angle J, I look and see that I have an opposite side, that I have a hypotenuse, and I have an adjacent side. Okay, so if I wanted to find sine of angle J degrees, then I'm going to get I'm going to use so I'm going to use the opposite side, which is 60, and then divide that by the hypotenuse, which is 61. Okay, so that would be part A. That would be my answer. Now, this is a ratio. Okay, and when I say sine of J, this is a number. Okay, and that number is equivalent to 60 divided by 61. Okay, it's pretty close to 1, but not quite. All right, so now let's do the same thing, but let's do this for part B. Okay, so part B, we're doing cosine of J. So we've got the same relationship. We've still got the opposite side of angle J, the adjacent side to angle J, and the hypotenuse. It's all the same. So in part B, if I were to say the cosine of angle J, then that's going to give me the adjacent side over the hypotenuse. And I got that by using the ka, it's so ka toa. So if I'm trying to find the cosine of some angle, which is angle J, I take the adjacent side, which is 11, and I divide it by the hypotenuse, which is 60. Okay, and that's the ratio that I'm looking for. Okay, now remember, cosine of J, this is a number. Okay, I treat it like a number. It has a value of 11 over 60. Okay, now the last one for this example is part C, which wants me to find tangent of angle K. Okay, so K is over here, so we need to switch our thought process for a second. I'm going to erase what I had for the other sides, because that was in relation to angle J. So now we need to switch gears, and we need to go, okay, here's angle K. Now, if I look at angle K, this is still my hypotenuse. This side length here is my adjacent side. And then this side over here is my opposite side. Okay, so things have switched. The opposite side and the adjacent side have now switched. The hypotenuse is the same. Now we're using tangent, so it's toa. So it's opposite and adjacent. So I'm going to take the opposite side, which is 11, over 60. I did this one wrong. This should be 61. Okay. Now remember, this is just like the other ones. This represents a number. And that number is a ratio of side lengths. Okay? Sorry, cosine of J, that should be 11 over 61. Okay, I made that mistake. So tangent of K is 11 over 60, opposite over adjacent. I had done the wrong thing. So got to be careful. I make mistakes. It happens. Let's go ahead and move on to the second example. Okay, and it tells me to use a special right triangle to write cosine of 30 degrees as a fraction. So let's check and see here. Now I'm going to draw my picture for the special right triangle. I'm going to call this 60 degrees. I'm going to call this 30 degrees. The side that's opposite of 30 degrees is always called S. The hypotenuse is 2 times S, and then the third side is always S times the square root of 3. Okay, so what I want to do, this is kind of an interesting example, and it'll kind of help us out later on when we look at the unit circle. But I'm going to do this. I'm going to call this 60 degrees and 30 degrees. And I'm going to start off with my simplest type of right triangle here. All right, 30, 60, 90 triangle. And I'm going to call this length S, call it 1. Okay? So if S is equal to 1, I can fill out all these other sides I would know that 2 times 1, this length is going to be 2, it's double that length. And then this third side is going to be this length 1 times the square root of 3. Okay? Now, if it's asking me to do cosine of 30, cosine of 30 degrees, okay, then what I can do is I'm going to take, let's go ahead and call this the opposite, the adjacent, and the hypotenuse. So given 30 degrees, this is my adjacent side, which is the square root of 3 over 2. Okay? And that's my fraction. Okay, now let's do something. Let's actually go to our calculator, and I'm going to type in, I'm going to hit the mode button first. I'm going to change my my angle measures. We're not going to use radians. We need to be using degrees here. Okay. I'm going to switch out of that. I'm going to quit out of this. And I'm going to then do cosine of 30 degrees. Now, I can type this into my calculator, and then I can hit enter, and it gives me this number, which is about 0.866. So I know that this value here is approximately 0.866. Okay? Now, once I've done that, all right, I'm actually going to see what, that's after I plugged in cosine of 30. Okay? Now, I have this where it says the square root of 3 over 2. So I'm actually going to go back to my calculator and plug that in, and I end up getting this. I end up getting, let me do square root of 3, enter, and then let's divide that number by 2 and see what we get. Oh, man, look at the same number. Exactly. Okay? So, you know, again, guys, these are all different representations of numbers. Okay? So when I say cosine of 30, it gives me this number, 0.866. This side length divided by this side length. Okay? The next thing I want to do is do this last example. And what it wants us to do is it wants us to find each length round to the nearest hundredth. Okay, you will need your calculator for this. I'm going to show you how to do this. But it wants me to find the segment length of BC. I'm going to call that X. Okay? Now I have this angle here, angle B, which is 15 degrees. Now I have to look at this, and I'm given the opposite side, and I'm given the adjacent side. And remember, we have SOHCAHTOA. Okay? So if I look at the side lengths that I've been given and the angle measure, okay, given 15 degrees, I'm given the opposite side and I'm given the adjacent side. That should look like an A. So because I'm given opposite and adjacent, I want to use my tangent function. So look at the equation I can set up. I can set this up. I can set up tangent of 15 degrees is equal to the opposite side, which is 10.2 being divided by x. Okay? Now, what I have here, guys, is I have a proportion. Okay? I'm going to call this over 1. So what I can do is I can just cross multiply and solve for x. Now, remember, guys, tangent of 15 is a number. Okay? Equals a number. All right? So if I cross multiply here, I'm going to get x times tangent of 15 is equal to 1 times 10.2. Okay? Now, guys, I'm operating with tangent of 15 just like I would any other number. Okay? I'm going to treat it like a number. So if I divide both sides by tangent of 15, okay, I can do that. It's a number. All right? Tangent of 15. It's a number. So I get this. I get x is equal to 10.2 being divided by tangent of 15. Okay? So now what I can do, let's actually plug this into our calculator and see what we get. We'll get an approximation. It's not going to be perfect. But I'm going to come to my calculator, and I get 10.2, and I divide that by tangent of 15 degrees, close my parentheses, and then hit enter. And I end up getting that that side length is about 38.06. So let's write that, all right? We get that this is about 38.06. Now the question is, I mean, is that reasonable? Okay, if this is 10 and that's across from a very small angle, then this side would be much larger, okay? And it seems to about make sense, okay? It seems pretty reasonable to me. All right, now let's do the same thing over here for QR. Okay, I'm going to call this X. Now, you're given 63 degrees here. All right, let me change up colors here. Let me go red. All right, this is called this X. This is 63 degrees. Now, given this angle of 63 degrees, I am given the opposite side, and I'm given the hypotenuse. So that tells me that I can use my sine function because it's SOH. Okay, I have the opposite side and the hypotenuse. This one's a little bit easier to see. Okay, I can write this. I can write sine of 63 degrees, okay, is equal to the opposite side, which is x, divided by 12.9. Okay, now what I can do here to solve for x, I don't have to set up a proportion. I can just simply multiply both sides by 12.9 and by 12.9, and I end up getting this. I end up getting that, put a decimal there. X is equal to 12.9 times sine of 63 degrees. Okay, so I can go ahead and plug that into my calculator, and I can then say, all right, I'm going to take 12.9 times sine of 63 degrees. Now remember, sine of 63 is a number, it's a ratio. Okay, and I can solve for x, and we get, what is it, 11.49? All right, let's write that one out. So we get that this is 11.49. Okay, does that seem reasonable to you? The hypotenuse is a little bit longer. That seems reasonable to me. Okay, so there's our answer for that. All right, now let's do for FD over here in this example. Okay, FD is the hypotenuse. Call that x. Now you're given 39 degrees. Now you're given the adjacent side, and you're given the hypotenuse. So if I take cosine of 39 degrees, then I'm going to get the adjacent side, which is 20, and divide that by x. Now this one I want to set up a proportion and solve. So I'm going to put that over 1. I'm going to cross multiply, and so I get x times cosine of 39 degrees is equal to 20 times 1. Okay, now if I divide both sides by cosine of 39 degrees and divide both sides by cosine of 39 degrees, all right, then I get that x is equal to 20 divided by cosine of 39 degrees. Now, guys, I'm operating with cosine of 39 just like I would any other number, because that's what it is. Okay, so now let me come to our calculator real quick, and we end up getting, let me do 20 divided by cosine of 39 degrees, and let me hit enter, and we get about 25.74. So, you know, this is really powerful, guys. What was it, 29.74? 25.74. Okay. 25.74. Let me write that. 25.74. Okay. And that was the longest side of that triangle, so it seems about right. 25.74. Guys, this is really powerful. This is a way for us to calculate the sides of a triangle given only an angle and a side length in a right triangle. Okay, so this is really powerful, something that we can do. This requires a little bit of practice. Again, all I'm using here is SOHCAHTOA. And I'm just setting up trig functions and equations, and then I'm solving for those variables. Now, the thing that you got to realize is that whenever I have tangent of a number or of an angle, sine of an angle, and cosine of an angle, those are all numbers. Okay, they're ratios. You can plug them into your calculator and see what they are. A lot of times what I would do, guys, is I'd kind of just mess around with these on my calculator until I got a number that made sense, given the lengths of the triangles. So in the next video, we'll talk about how to use this in to find the angle measures.